Right, so next is the multiplexer. So sometimes we call the mux. Okay, so the function of the multiplexer is the data selector lah. Alright, so the digital multiplexer is the communication circuit that selects the binary information from one of the many input line to and directs it to the single output line. Alright, so the selection of particular line is controlled by the set of select inputs line lah. Alright, so for example we have the 2 bits marks. Okay, that means we have the A and B lah, 2 bits. Okay, 2 bit marks. Alright, and then the S, this one S, we call the select input lah. Actually this S function to get the output here. That means we have two inputs here. Okay, what is the output here based on these select inputs? Okay, these select inputs. Okay, for example, this is some is the logic expression logic expression on the 2-bit marks. Okay, and then from this logic circuit we can draw the truth table lah. So for example, the logic expression is S bar A plus SB. Alright, so this is truth tables. Okay, for example, if the output on the select is the 0, that means we select the D not here, A lah, A as the output here. Okay, if the S is the 1, that means we select the data in the B here. Alright, so the output here will be B. Okay, B here, or sometimes we call it D1 lah. Okay, and then for example, for 4 times 1 mux multiplexer, that means we have 4 data, but we have 2 select inputs here. Okay, 2 select inputs here. For example, S0 and S1. Okay, so the output here, okay, this is the output based on this one, this data select. For example, we have 0 0. That means 0 0 we know is a 0, so we be select the D nots. Okay, so the data inside the D not will be output here. So that's why you can get if S1 0, the S0 0, S1 0, that means the output will be D naught here. So this one is the D naughts. Okay, and then equal to data inside the D naught lah. For example, on the data D naught we have 0 1 1, so the output will be 0 1 1. Okay, and then if for example the S0 will be 0 and S1 will be 1. Okay, so that means we have D2. Okay, D2, the output here will be D2. So what is the data inside the D2 will be output lah, data output here. Right. Okay, from this truth table we can come up with this logics. Okay, this Boolean expression lah. Okay, this Boolean expression. Okay, this is a practical 8 times 1 multiplexer available in market. Okay, maybe you can find this one lah, the data sheets. Okay, on the Googles. Okay, so this is a logic symbol and this is IC lah. Okay, you can see this one, some example using the multiplexer lah. Okay, so this one we have 3 select inputs. Okay, we have 3 select input and we have 8 data selection lah. Data we have 8 data, so output will be 1 lah. And then this is invert of outputs. Okay, Y bar. Okay, this is Y and then this is invert of Y lah. Okay, right, so how to design a logic logic design using the mux. Okay, so if the Boolean expression available, so there is a step we have to follow. First, observe the number of input variables, how many input variables, and then next, second step, we have to construct the truth tables. Okay, and then we have to choose. Okay, choose the selector lah. Okay, choose the selector, that's, or sometimes we call the control variable from any of the input variables. Okay, there is some example. This is here some example. If 4 times 1 mux, that means 2 power of 2. 2 power of 2 equal to 4 lah. So power of 2 will be the data selector lah, the data selector here. For example, this one for 8. Okay, 2 power of 3 will be 8. So 3 will be the data selector. For example, we have 16. Okay, 16, that means 2 power of 4 equal to 16. That means we have 4 data selector. Okay, we have 4 data selector lah. And then step number 4, we have to design the circuit lah. Okay. Okay, this some example. We have the Boolean expression. Okay, this is some Boolean expression. Okay, from this Boolean expression also we can draw the circuit here. Draw the circuit using the standards. Okay, using this Boolean expression. So this is logic gate lah, logic circuit for this Boolean expression. You can see too many logic gate lah. Too many logic gate. And then for the next step, maybe you can use the K-maps, or we can use the De Morgan or rules to simplify our Boolean expression. For example, this is using the De Morgan or the rules, and this one will be K-map. Suppose the both answer will be same. Okay, this is some examples. Okay, they use the rules. They use the rule, and then this is simplified lah. Simplified. This simplified based on the Boolean expression given. Alright, this one from the K-map lah. Okay, that's why you can see. So this output and this output will be same. Okay, suppose will be same. Okay, next, after you get the simplified circuit, you can draw lah. Alright, okay, so this is, we have 3. Okay, we have, maybe we can set this one. A and B is the input, C is the data selector, and then this one F will be outputs. Okay, output. Okay, so logic design using the 4 times 1 mux multiplexer. Okay, for example, we have the Boolean expression here. Okay, Boolean expression here. Next, okay, you can draw the truth tables. Okay, alright, so this is the truth tables. Okay, for this one, we have that I mentioned, you have to select. You have to select the select input, which one you want to select. For example, this example, they use the A and B as the select input. This means this is A and B is the select as not S1. Okay, as not S1 lah, for example. Okay, and then this is based on the previous expression. You can see this one. 0, 0, 1, 0, 1, 1, 1, 0, 0. Okay, 1, 0, 1. Okay, that's why you can get this one 0, 0, 1, 1, another one, 0, and 1, 1. Okay, 1, and the rest okay, you get this one based on the Boolean expression. Alright, so that I mentioned to you, we use A and B as the data selector. That means we have 4 possible inputs. Okay, so 4 lah. Alright, so you can see here as the C. So the output here C, so this one will be C. So that's why A naught, this one we call the A naught, will be C. Okay, next you can see this one. Okay, the input will be here, and then the A1 also C. Okay, you can see C here. That's why C. Okay, for this one, the both is 1. Okay, the both is 1, so automatic A2 will be 1 lah. This one, the both is 0. That means A3 will be 0. Okay, and then you have C1 0. Okay, this one you can draw the circuit here. So you can see this one. So that's why A0 and A1 connect to the C. Okay, and then A2 will be positive 1. Okay, there is some, we call the positive 5 volts. Okay, to on the IC, we use the 5 volts. Okay, and then 0 will be ground. Alright, this is some example. If we use the 4 times 1 multiplexer. Okay, for example, if we use the 4 to 1. Okay, 4 to 1. Another example another example. This. Okay, so based on this one. Okay, you can see another example. This is Boolean expression. Okay, so for example, we have 1, 1, 1, 1. That's why you can see this one. 1, 1, 1 will be 1. Okay, 1, and then the rest lah. Okay, this one 4 to 1. This means 4. We have 4 here. Alright, so you can see this one. For example, this one, we know this is the one active. So this one will be, the both will be ni lah. So that's why you can get this one C D bar. You can see C D bar, and then this one will be C D. That's why you can get this one. For example, this one all will be 0 lah. That's why A1 will be 0. Okay, this one here will be 1 kan? Will be 1. Okay, so the answer will be C bar D. Okay, C bar D. Alright, for this one we have 1 here and 1 here. So 1 here, so the answer will be C bar D bar, and another one C D. Right, so that is for A3 lah. Okay, this is A3, and then you can use, okay, you can draw the complete circuit. So this one you have to do it yourself lah. Okay, try complete the circuit lah. For example, so this one, okay, A0 will be C, we have connect to C, and then A1 connect to the ground, and then we have the inverter C. This one we have inverter from C to, and then we have the logic N here, and then another one input from D lah. Okay, and then for the A3. Okay, that's the circuit lah. Okay, next we try go for the 8 times 1 multiplexer. Okay, repeat, use the same example 4. Okay, this is some example 4 lah. The truth table will be same. Okay, but they choose A, B and C as the selector. So A, B, C is the selector lah. Okay, so you can see as a selector. Okay, this one 0, so A0 will be 0. Okay, this one A1 will be 1, 0, 0. Okay, this one will be D. Okay, this one will be D. This one, okay, 0. This one will be C, D bar, and this one will be D. Alright, so this one let me show to you. 0, 0, D, 0. Okay, D, 0, D bar, D. Alright, and then you have to draw the circuit lah. Okay, for example, A0 will be ground lah, and then this one will be to the supply lah, 5 volts. Okay, and then A2 will be ground. Okay, so A4 will be go for the D, and so on. Okay, this is circuit lah for the example for the 8 times 1 multiplexer. Okay, next we go to demultiplexer.